All right, let's talk about the periodic table. I know. It can look like this big, scary wall of letters and numbers, but it's actually one of the most brilliant and powerful tools ever created. Today, we're going to take a guided tour to break it all down, and we're starting with the biggest question of all.
I mean, that's a huge question, right? Everything. Everything you see, everything you touch, all the air you're breathing, it's all built from this fundamental set of building blocks. But how in the world do you even start to organize all that cosmic stuff?
Okay, imagine you're trying to cook the most complex meal ever, but your kitchen pantry has over 100 different ingredients, and none of them have labels. That's kind of the challenge scientists were facing. They had all these elements, but no recipe book, no organization, just a whole lot of chaos.
But what if there was a cheat sheet? You know, a map that doesn't just list all the ingredients, but actually tells you how they're going to behave and who they're going to be friends with. Well, that's exactly what the periodic table is. It's the beautiful, elegant solution to all that elemental chaos.
And here's the key to this whole masterpiece. It is not random at all. First, all the elements are lined up by their atomic number. That's just how many protons they have. But the real genius, the part that changes everything, is how they're arranged so that elements with similar personalities all wind up in the same columns. It's like they're members of a family.
So let's quickly break down this layout. The horizontal rows going across, those are called periods. And the vertical columns going down? We call those groups. The easiest way to think of it is like a city grid. The period is kind of like the street address an element lives on. But the group? Oh, the group is its family name. And just like any family, all the elements in the same group share similar traits and behaviors. Why? It's because they all have the same number of electrons in their outermost shell. And that outer shell, well, it pretty much dictates their entire personality.
So if the groups are families, then you can think of the whole table as being split into these big, distinct neighborhoods. And broadly speaking, there are three of them. You've got the world of metals, the world of nonmetals, and this kind of funky border town right in between.
So over on the left side of the table, and it's a huge area, that's the neighborhood of the metals. These are your shiny elements, the ones that are great at conducting electricity and heat. Then, way over on the right side, you find the nonmetals. And for the most part, they're the complete opposite. And right between them, separating these two worlds, is this really cool zigzag line.
This is where the metalloids live, right there on that border. And they literally have a foot in both worlds. They have some properties of metals and some properties of nonmetals. And as you're about to see, that very unique position makes them unbelievably useful, especially when it comes to technology.
Okay, so now that we know the neighborhoods, let's zoom in a little bit and meet a few of the most famous families. Each one of these groups really does have its own distinct personality. Just look at this contrast, it's wild. Way over on the far left, you've got the alkali metals, like sodium. They have just one lonely electron in their outer shell, and they are desperate to give it away to feel stable. When they do, they get a positive charge. Then almost on the complete other side, you've got the halogens, like chlorine. They are just one electron short of a full set, so they are super aggressive about stealing one from someone else, which gives them a negative charge. And then you've got the cool kids in the...
That's Group 18, the noble gases. These guys are perfectly content. Their outer electron shells are totally full, so they have absolutely no need to react with anyone else. They really are the stable, unreactive introverts of the elemental world, just happily keeping to themselves. You know that awesome glow in a neon diner sign? That's a noble gas, just doing its thing. So, okay, we've got this amazing, beautifully organized chart, but what's the point? Why does understanding this elemental map actually matter in the real world? Well, it turns out it's kind of everything.
Seriously, just think about it for a second. Metals, like copper, they form the literal backbone of our entire electrical grid. Nonmetals, like oxygen, they are the reason we can take our very next breath. And what about those metalloids from the border town? Well, silicon is the beating heart of every single computer chip that powers our modern world.
And that is the real magic here. The periodic table isn't just a boring list, it's a predictive tool. By knowing an element's address, its group, and its period, we can make a really good guess about its personality, how it's going to behave, and what kind of job it can do for us out here in the real world. It truly is the ultimate cheat sheet for everything.
So that brings us to a final thought I want to leave you with. Now that we've seen how all these different elements play a part, from the superreactive metals to the essential nonmetals to those tech-savvy metalloids, which family, which one of these groups do you think is the most indispensable to our daily lives? It's actually a much tougher question than it sounds. Something to think about. Thanks for joining me on the tour.